Rural Morgan County, Ohio, late 1967. A convoy dispatcher, working for one of several regional trucking contractors hired onto this job, stands at a staging yard checking a manifest against a line of tandem tractors pulling multi-axle lowboys Kenworth and international trucks hitched to Talbot and Trail King-style trailers, each one carrying a single numbered piece of what will become, once assembled, the largest walking dragline ever built. This load will not travel as one shipment. It will travel as roughly 260 separate truck loads, alongside some 340 rail cars, each one a structural or mechanical component too large to combine with any other boom sections, base plates, machinery house panels, cable drums headed for a strip mine site where Central Ohio Coal Company's crews are waiting to erect a 27 million pound machine that has never existed anywhere in one piece. The dispatcher's job is not to move one impossible object. It is to move 260 merely difficult ones, in a specific sequence, without a single load arriving in the wrong order or damaging a rural road never built to carry anything like it. Before we continue, if this kind of documentation is what you've been looking for, consider subscribing. Every video on this channel goes into one specific element of heavy-haul trucking in America between 1945 and 1995, what a specific transformer, bridge girder, or oil field haul actually required, what the engineers, drivers, and escort crews had to calculate and execute, and what those loads actually became once delivered. The power plants, the bridges, the mines that quietly ran the country, not spectacle about big trucks. The documented technical reality of a high-stakes logistics trade. What Big Muskie's shipment shows is that sometimes the heaviest single-day engineering challenge in a project isn't building the machine, it's the hundreds of individual decisions required just to get its pieces to the same field. And if someone in your family drove convoy trucks, worked heavy construction, or had any connection to Ohio coal country in this era, put it in the comments. What do you remember them saying about it? There's more of this specific machine story still to come, including what 200,000 man-hours of on-site construction actually looked like once every truck had arrived. Back to the road. To understand why this shipment required 260 trucks and 340 rail cars instead of one extraordinary load, you need to understand the basic constraint every dragline this size runs into. Big Muskie weighed 27 million pounds finished, stood nearly 22 stories tall, and carried a 220 cubic yard bucket dimensions and weight that made shipping it assembled, by any method, physically impossible. There was no road, no rail line, and no barge in the country that could carry a complete 27 million pound walking dragline in one piece. The only way to build a machine this size was to build it in pieces small enough for a single truck or rail car to carry legally, ship each piece separately to the mine site, and reassemble the entire structure, there meaning the shipping operation itself was not a footnote to the engineering. It was one of the central engineering problems the entire project had to solve before a single bucket of overburden could be moved. Every one of those 260 truckloads still had to reach the mine site on rural southeastern Ohio roads that had never been built with anything like this cargo in mind. Getting a permit to move an oversized or overweight load across Ohio's road system, in this era as now, required more than simply requesting permission. It required a structural analysis of every bridge along the proposed route. Because a bridge's posted weight limit exists precisely to describe the maximum load its structure can bear without risking damage or collapse. A convoy hauling components this heavy could not simply choose the shortest route between the fabrication point and the mine. The route had to be built, bridge by bridge, around which crossings could actually bear the load and which could not. With any bridge rated below the load's weight, either avoided entirely or crossed, under specific restrictions, reduced speed, single vehicle crossing only, sometimes escort coordination with local authorities to control opposing traffic, while a load that took up most of a two-lane road's width made its way across. For a shipment moving 260 separate loads over an extended period, this was not a single route planning exercise. It was, in effect, 260 individual route decisions, each one accounting for that specific load's exact weight and dimensions against the specific bridges standing between the plant and the mine. For the drivers themselves, this convoy work demanded a different kind of skill than the single dramatic bridge crossing this channel has documented in other videos. There was no single defining crossing here, there were dozens of them, spread across weeks and months, each one requiring the same disciplined attention as the last. A driver pulling a Talbot or Trail King-style lowboy loaded with a section of dragline boom or a machinery house panel had to hold a Kenworth or International tandem tractor at whatever speed the day's specific bridge or road restriction demanded. Adjust for trailers handling with a load that shifted the vehicle's center of gravity in ways an empty trailer never would, and do it again the next day and the day after that, for as long as the shipment took to complete. This was not one moment of extraordinary skill under pressure. It was sustained, repeated competence, the same careful judgment applied to a different bridge, a different load, a different stretch of narrow county road, day after day, for months, with the same margin for error as any single dramatic crossing, and none of the singular attention a one-time move might have received. When each truckload finally reached the Muskingum mine site, the road crew's job ended, and a different, equally demanding job began, turning hundreds of individually shipped components back into a single working machine. Erecting Big Muskie on site took approximately 200,000 man-hours, spread across roughly 2 years of assembly work, following about 2 years of fabrication, meaning the total project. From the first steel cut to the machine's first bucket of overburden in May 1969 ran close to 4 years, and the shipping operation this video documents sat at the exact hinge point between them. Every truckload delivered to the site had to arrive in a sequence that matched the erection crew's actual construction schedule, because a component that arrived too early sat exposed to weather and took up space the crew needed for something else, while a component that arrived too late could stall an entire crew waiting on a single missing piece. The Convoy's real achievement was not simply getting 260 loads to a mine site. It was getting them there in an order that let a 2-year, 200,000 man-hour construction project run without the shipping schedule becoming its own bottleneck. To understand why a company would commission a machine this difficult to ship and erect, you need to understand what Central Ohio Coal Company was actually solving for. The company's mine property extended over roughly 110,000 acres of hilly terrain, feeding coal to the Muskingum River Power Plant at a moment when rising post-war electricity demand meant that plant needed more coal delivered faster than the company's existing equipment could economically strip and expose. A dragline this size with a bucket capable of moving 325 tons of overburden in a single bite let Central Ohio Coal reach coal seems buried under more earth than a smaller machine could economically remove, while also supporting the company's land reclamation commitments once a seam was exhausted. That combination deeper, more efficient overburden removal paired with a reclamation obligation is what justified accepting a shipping and construction challenge of this scale in the first place. The 260 trucks and 340 rail cars were not an unfortunate side effect of an ambitious design. They were the price of a specific economic and engineering decision. That a single machine capable of doing the work of several smaller ones was worth every one of the individual logistics problems required to get it into the ground. Big Muskie began production in May 1969 and ran continuously, stopping only for meal breaks, repairs, and Christmas Day until it was retired in 1991, moving an estimated 483 million cubic yards of overburden over its 22-year operating life. Every one of those 483 million cubic yards moved because 260 trucks and 340 rail cars had, over roughly 2 years in the late 1960s, delivered every individual piece of the machine to a rural Ohio field in a sequence that let a construction crew turn separate components back into one working structure. The shipment this video documents is easy to treat as a footnote to that 22-year production run, a brief, forgettable logistics exercise before the real story of the machine begins. But without it, there is no 22-year run. Every ton of coal Big Muskie ever helped uncover, every kilowatt the Muskingum River Power Plant ever generated from that coal, traces back through 200,000 man-hours of on-site assembly to a specific truck, on a specific rural road, carrying a specific numbered component to a mine site that could not build the machine until that exact piece arrived in the right order, at the right time, over a bridge rated to hold it. If this channel is going to keep documenting what it actually took to move America's heaviest industrial loads before digital systems took over part of the job, subscribe. There are more transformer hauls, more bridge crossings calculated to the ton, more convoy operations like this one where the real story wasn't a single dramatic move, but hundreds of ordinary ones executed correctly in sequence, and more of the specific people who coordinated them, who were rarely described as remarkable at the time because getting the load there on schedule was simply the job. Whether or not anyone in your family had a connection to Ohio coal country in this era. What this shipment shows is that America's mid-century industrial build-out depended on a category of logistics work that gets almost no attention once the finished machine is running. The sheer coordination required to get hundreds of individually oversized pieces to the same field in the right order without a single bridge failing under the weight. And if you have a connection, a relative who drove convoy trucks, worked heavy construction, or had any tie to Central Ohio coal or the Muskingum mine, put it in the comments. What do you know about what that work actually demanded of them? There's more of this specific industrial world still to document, including what happened to the region once Big Muskie's operating life ended in 1991. Big Muskie's shipment was completed in 1968, and the machine cut its first bucket of overburden in May 1969. By the time the dragline was retired in 1991, hydraulic excavators, truck and shovel fleets, and improved route permitting systems had already begun replacing the specific kind of oversized convoy logistics that had delivered it GPS-assisted route planning and computer bridge load analysis would, within another 2 decades, do in minutes what 1967 engineers had worked out over months of manual survey and calculation. What the newer systems gave the industry: faster permitting, standardized bridge load analysis, route planning that no longer required a surveyor to physically walk every crossing. What they did not need to solve twice: the specific, accumulated judgment of a convoy dispatcher sequencing 260 individual loads by hand, and of drivers who held the same disciplined care across dozens of ordinary crossings that no single one of them would ever be remembered for individually. The dispatcher at that 1967 staging yard did not know that the machine his convoy was delivering, piece by piece, would run for 22 years and move nearly 500 million cubic yards of earth. He knew only that truck number after truck number had to leave in the right order, cross the right bridges at the right speed, and arrive before the crew waiting at the mine ran out of the last piece they needed to keep building. The mine had asked for pieces in a specific order. No one had needed to tell the drivers twice.